Hello, welcome to Block 3, Equality and Equivalence, Lesson 5. I'll share my screen. So, in your previous lesson, you learned how to solve one-step equations involving multiplication and division using inverse operations. In today's lesson, you're going to learn the meaning of like and unlike terms. This is a very important and fundamental concept in your understanding of algebra. But before we start, I would like you to pause the video for about 3 or 4 minutes and have a go at the retrieval questions. So if you notice, these cover some of the things we have covered in our previous lessons. Okay, assuming you've paused the video, you've really thought about this work, you've worked through it, let's look at the answers and discuss them. So, question 1, you were asked to match the terms on the left with the equivalent card on the right. So, this tests your understanding of how to write algebraic terms in different ways. So, note here, x to the power 2 or x squared is x times x. 2x is 2 times x. 2x squared means 2 times x, and then 2x in bracket to the power 2. Don't forget this, you should remember it means this multiplying itself. Okay, so when you actually decompose it or break it down, this is what it looks like. So it's like having this multiplying itself. And then next one, you asked, in the term 3x, the letter x is a variable. So remember, in our very first lessons in algebra, we said the letter, it could be any letter of the alphabet, it is called a variable. And the number sitting right next to the letter is called the coefficient. It's important you do not forget these words. We're going to be using them in subsequent lessons or in other lessons, future lessons. Okay, let's do some new learning. So, what are like terms? It's important you understand the meaning of some of these words in maths when we use them. So, like terms are terms, so algebraic terms with the same variable. So, you now know what variable means. So, the same letter and the same power. So power is the little number you write on top of the letter. So for example, x to the power 2, which we sometimes call x squared, 2, the little 2 on top of x is the power. Okay? Or if you have a squared or a to the power 3, the little number on top is called the power. So like terms are terms that have the same power, the same variable, and the same power. But unlike terms won't have that. Okay, so unlike terms will there are terms with different variables or different powers. So it could be different variables or different powers. Let's look at some examples. Okay, thinking about what the way we've explained what like and unlike terms are, what do you think? Now look at these two. You'll see that 5 has C and 3 has C next to it. So first we have satisfied the first condition. We have the same letter C. What about the power? Yes, we have the same power. So in maths, in algebra, this is power 1. So if you do not see any number on top of the C or on top of any letter, it means it is power 1. But we don't often write it. So we know that it's something you just know. Okay. So you should know it now. All right. And then this one. So they are like terms. Okay, what about this one? What are you thinking right now? Okay, they're like terms. Okay, they're like terms. Okay, what about this one? I'm sure you're thinking the same way I am thinking right now. They have the same letter, but they do not satisfy the second condition of having like terms. They don't have the same power. So they are unlike terms. Okay, they have different powers. What about this one? All right, I know what you're thinking. Said, there is no letter. What's this about? Okay, you should know that in maths we call the numbers constants. Okay, we call the numbers constants. Now, another way I want you to think about this is to really expand your thinking. Why they are equivalent. What if we assume any letter, right? Any letter. If we assume letter A and we put letter A in front of each of them, one thing, big secret, no, not really a secret, but I want you to be thinking ahead. In maths, anything to the power 0 is equal to 1. So even if I put any of the letters of the alphabet and put 0 as the power, because we don't really have it, this is like saying 5 times 1, and this is like saying 3 times 1, because any letter to the power 0 is 1. Well, I want you to have that, just have it at the back of your mind. We won't use it now, but we'll use it sometime in the future. Maybe year 8, or possibly towards the further studies in your year 7 maths. But you should know that constants are like terms. So any number without a letter next to it is a constant. So they are like terms. Okay. All right. Here is something to think about. Dora says, we can call her Dora or even call her Sophie. 4C and 4D are like terms because they both have 4 in them and the power of 4 is the same in both terms. Do you agree? Have a think. Do you agree? But remember, before you make your decision, remember what we said like terms are. Like terms must have the same variable and the same powers. Of course, she's wrong. Okay. And the reason is like terms must have the same variable, which is the letter. You should know that by now. And the same powers. The letters must have the same powers. Okay. What we've learned so far before you have a go at the questions is what like terms and unlike terms are. So you should know that like terms must have the same variable and the same powers. And you've also learned that if you just have numbers, numbers are like terms because we call them constants. All right, pause the video and have a go at these questions for about 3 minutes. Okay, assuming you've paused the video and you've really thought about these questions, you've really worked hard, here are the answers. Let's discuss them. So for the first one, you were asked to simply match the like terms. And you can see these. Okay. They are like terms. You can see it has the letter H and the power is the same. Look at this. They're like terms. It has the letter H and the powers are the same. So are these. Now, don't get confused about this because remember in algebra, we can simply, these are commutative. Do you remember commutative? If I can write this in algebra, remember, we can write this as 3a, 3 times a times b. And we can write this as 5 times b times a. Now remember, in algebra, multiplication is commutative, meaning you can swap things around and you still have the same result. So this is the same thing as 5 times a times b. So really, this is actually 5ab. All right, let's move on. And question 2, you were asked, tick to show whether the terms are like or unlike. All right, so you're just looking at these and then you know the principle now, what like terms are and what are unlike terms. Okay, let's move on. Here are questions 3 and 4. I would like you to pause the video and have a go. You can pause the video for 3 minutes and have a go at these questions. Assuming you've paused the video, you've really thought about the questions. Here are the answers. Let's discuss them. Here you were asked question 3a to circle the terms that are like 7xy. Of course, this one, yeah, we have the same letters and the letters have the same powers. And that one, remember, this is the same thing as 5xy because 5yx is commutative to 5xy. We can swap the letters, yeah, which I explained earlier just now. All right, here you'd ask to circle the terms that are like h squared. Of course, these ones. All right. So you can see what are the conditions for like terms. You must have the same letters and the letters must have the same powers. And that is satisfied here. All right. Don't bother too much about the coefficient being negative. All right. Circle the terms that are like 2p. Again, we need to have terms that have p and the power must be 1. And these are all like terms. Okay. Don't bother too much about the coefficient. Here is the answer to question 4. Here, Dora has these expression cards. These are like terms because they all contain just the letter X. Dora has forgotten the second condition. They must have the same powers. All right? So Dora is wrong. Yeah. So they must have the same powers, not only having the same letters. All right. If I say you should write down 5 terms that are like 3a squared, I'm sure by now you should be thinking, okay, I can write whatever I want. But I must satisfy the 2 conditions for like terms. I must satisfy that. So remember, this is a very quick task for you to think about and to do. Maybe discuss with somebody sitting next to you that you're watching this video with. You can write anything you want, but remember the 2 conditions to get like terms. It must be h and it must have the power squared. Okay, I assume you've written some really quickly because this is easy. You can write anything. You can even write 1 million h squared. You can even write half h squared. You can even write 0.0001 h squared. They still a like term. Yeah, provided you satisfy the condition. And here are the ones you could get. You could get something different. Okay. Now, something I want you to begin to know is how we write things in algebra, because this is a very important skill. You see this here, we can write it as h squared over 3, right? So this here is the same thing as that. And then in turn, we can write this as 1 over 5 h squared. So some of these little things, we're going to be using them at some point in the future, but you should know, how things work. Yeah. Okay. Let's move on. All right. And then next, what about unlike terms? Yeah. Write down unlike terms that are unlike 3a squared. Now remember, what are the conditions? We must have, to get these like terms, we had to make sure we had the same letters and we had to make sure we have the same powers. So if you just want to, write whatever you want, you just make sure, okay, whatever I write, I'll make sure I model things up. So either I'm not going to have the same power or just write different letters. Yeah. And then that, you obviously got unlike terms in your hands. And so here are some of the ones we could get. I'm sure you've written some. So here are the ones you could get. Anything, anything. You could even write 3h to the power 1 million. Okay. All right. All right. Okay. So what we've learned so far is how to write like and unlike terms. Okay. We've also looked at different things. I've told you a different way of writing this. Okay. You can write this as h squared over 3. It's the same thing. And you can write this as 1 over 5h squared. Yeah. And um, we've also learned how to write unlike terms. You just need to make one of the conditions wrong. So either you have a different letter or you have the same letter but different powers. All right, have a go at the rest of the questions. Here are questions 5 and 6. You can pause the video for 3 minutes and have a really good go at questions 5 and 6, practicing what you've learned. Okay, assuming you've paused the video and you've really thought about this, you've worked hard on this, here are the answers. Let's discuss them. Here, you asked to write 5 different like terms for each term. Okay? By now, you should know how to write like terms. So you just need to make sure that you have the same letter and the same power. That's all you need to satisfy. You can write whatever you want. You just need to have the same letter and the same powers. Okay, this is the answer to question 6. Say, explain why these are like and unlike terms. Okay, again, remember, we need the same variable and the same powers. Yeah, variable means the letter. Don't forget. And then to have unlike terms, you just need to make one of them not true. So either you have a different variable, which you call letter, or a different power if you have the same letter, or what we call variable. All right, here are questions 7 and 8. You can pause the video for 3 minutes and work through them. Okay, assuming you've paused the video and you've really worked hard on this, here are the answers. Let's discuss them. So here you were asked, sort the expressions into sets of like terms. Find as many sets as possible. And these are the like terms. You see them? They're all the same variable with the same power. This one, look, all the same variable with the same powers. Do you remember what we call these again? Let me show you how we spell it for those of you who may not really be good with how to spell constant. These are constants. So don't forget, the numbers are constants. Then look at these. All the same variable and the same powers. All right. Let's look at the answers to question 8. Here you ask, are 20r squared p and 20p r squared like terms? Yes. Don't forget, these can be commutative. Yeah. So what did we say like terms are? They must have the same power and the same variable. Now, do not get confused having r squared p and p r squared, because remember what I explained earlier, you can swap these around. Yeah, r squared times p is same thing as p times r squared. So the same variables, P and R, and the same powers. Then here, you ask, are these and pi like terms? Yes. So pi is actually a constant. But is this constant? If you press your calculator, you see that you have long number. So 3.142 something, something, something. Yeah. So they are all constants. Yeah. Okay. That brings us to the end of our lesson. So what have we learned so far? In this lesson, we have learned how to understand what like terms and unlike terms are. Like terms must have the same variable and the same powers. Unlike terms, to get unlike terms, you just need to vary one of them. So you just need to have a term that has a different letter or a term that has the same letter, which we call variable, but different powers, right? So until next time, take care and bye bye.